All right. We got lesson 4, trigonometry. All right, the stuff for this one, I'm going to also let you know, if you would like to write some things down on a note card right now, I will hand them out as well. Whoops. But the stuff you're going to do today, you're going to be finding trigonomic ratios using right triangles. And then I'm not going to worry about that second part yet. We're finding the ratios and that sort of stuff. We'll be going over what sine, cosine, and tangent, what they all mean. Okay? So I will hand these ones out. I'll hand you guys note cards if you'd like it. But today it's mainly understanding kind of how to get the fractions. It'll be a 3-day lesson. Letting you guys know. So today is going to be a work day, a teach day. Tomorrow will be just a work day. And then Thursday is going to be a worksheet where you're actually getting the degrees and you're trying to figure out the other angles to a triangle. Every single person needs to bring a calculator that has sine, cosine, tangent. You guys should have them. Most of you had them to start the year. I had another one that's now disappeared again, so I'm completely out of any calculator that can do that. Okay? So I will let you guys write some of these ones down, but I'm going to explain it all in great detail. But sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over the hypotenuse. And then tangent is going to be opposite over adjacent. I'll pass out note cards if you want to write this down so that way you can just have this to use for all the assignments. You're welcome. Thank you, sir. Thank you. And if you're writing this stuff down, don't really worry about this side over here too much. You can if you want. I'm going to explain it all. The biggest part is just using this equation there.
Are those just circles of like?
So it stands for theta. I'm going to talk about it in a second. It means like if I choose either angle A or angle B. I don't have to write it two different ways as long as I say, this is going to be what I use for this specific angle. This specific angle, this specific angle. Maybe about 30 more seconds. Okay, so I kind of wrote them up here. I'm going to discuss it a little bit. When we look at these triangles, we're using the trigonometry portion of this, the sine, cosine, and tangent. The very first part we're going to talk. Okay, there'll be some different stuff that we'll go on to later in this chapter. But these formulas are all going to work when we deal with right angles. Okay, so this stuff here to use these formulas is going to be specific for right angles. Okay, so from this right angle in the corner, the longest side, the one that's always across from it, exact same name when we deal with Pythagorean theorem. What's this one called? Hypotenuse. Yeah, so no matter what, okay, no matter what, this value over here, the C value, across from here, this one is always going to be the hypotenuse. Guaranteed. Okay, so it's going to have the longest value for all of these. Just guaranteed it's always going to have the hypotenuse. Here, I'm going to... So when I'm looking at these kind of shapes, as I kind of wrote them over here, I've made this little theta sign, meaning I don't know exactly which angle I'm going to write. I wrote it, or the book has it this way, so you could write it down 6 different ways. But every single time you use sine, it's always the opposite over the hypotenuse. It's always the adjacent over the hypotenuse for cosine. It's always the opposite over the adjacent for tangent. Guaranteed, no matter what, that's what it is. Okay? So, understanding that portion of it, you shouldn't have to write it 6 different times. You can really just write it 3 different times. Sine is always going to be the opposite over the hypotenuse. Cosine is always going to be the opposite over the adjacent. Or sorry, adjacent over the... Yeah. Okay, the adjacent over the hypotenuse, and then tangent is always going to be the opposite over the adjacent. When, depending on who you talk to, depending on what class they're in, you ever heard people say Sakatoa or Sokotoa? Not Sacagawea, it's a dollar bill or dollar coin. Close though. Okay, so some people, when they're trying to kind of memorize this, if they don't have a note card, they use this little phrase, Sokatoa. It's kind of written like this. They use that kind of shorthand abbreviation. So I'll kind of, I'll just zoom down for it. That's Sokatoa. So sine is the opposite over the hypotenuse. Cosine, adjacent over the hypotenuse. Tangent, opposite over adjacent. That's kind of where this little shortcut way goes through. So if you need to remember it without having a note card, that's kind of a little, I don't even know the phrase for that. It's not even like a mnemonic device, but. So every single time, sine will always be the opposite over the hypotenuse. Cosine will always be the adjacent over the hypotenuse. Tangent will always be the opposite over adjacent. Okay. All right. You guys kind of have that written down. I'm going to jump into this picture here as best I can. So I drew my picture to kind of be similar with this one over here. I'll make it a little bit darker so there's not reflections. I don't know if anybody else has a reflection, but I sure did. All right. So when we have this written down, I want to point some things out because I know they use two of the same letters. Whenever they're referring to the capital letter is referring to the angle itself. Okay, so capital A is the angle for A. Capital B is going to be the angle for B. Capital C, that's going to be a 90-degree angle, but it'll be the angle for C. So if I'm looking at A, this angle right here, and I'm trying to find it. So if they give us all the sides of a triangle, we can use this trigonometry, the sine, cosine, tangent, to figure out what the degrees actually are. All right? So from this angle up here, if I want to figure out what these degrees are for sine, sine is going to be the opposite over the hypotenuse. So the opposite the opposite side of angle A is going to be this one all the way down here. So I'm going to draw on this so I can show you. The opposite for side A, or for angle A, is going to be side A. So that's where that opposite came into play. Over the hypotenuse is always going to be this one. So like on this very first one, it says opposite over the hypotenuse. So that's where I got to the side A over the hypotenuse. This first part of the lesson, the stuff we're going to have you guys do tomorrow after I teach it today, is not going to be solving what those angles are right now. It's mainly understanding which numbers will line up in which spot. Again, it's going to be really, really structured to make sure you guys get this set before we go on to the next one. So for sine of A, opposite over the hypotenuse. If I was looking for the sine of B, B is right here. The opposite side of B would be this one over the hypotenuse. That's where these letters were coming from. I wanted to make sure I showed it to you before I got to those first examples. Okay, so that's the sine. Sine is going to be the opposite over the hypotenuse. When I'm looking at the cosine, so if I'm looking for the cosine of A, I'm going to do this one next. Cosine is the adjacent. So which side is actually touching this angle? This is always the hypotenuse. Guaranteed, it will always be the hypotenuse. So what side is touching this angle for the cosine of A? That's where I get this side B. So adjacent means it's actually touching that angle. Make sense? So adjacent is touching, opposite means it is not touching. So cosine of A would be the adjacent, so B over C. I'm looking at the cosine of B, this one here. The side that's touching B would be A over the hypotenuse. And the very last part is the tangent. Tangent's always going to be the opposite over the adjacent, so you won't use the hypotenuse at all. But if I'm looking at the tangent of A, it'll be the opposite, so the one across from it. So it'd be A over the adjacent, so A over B. That's where these numbers are coming from, or letters are coming from. I'm going to go on to the examples now, but I wanted to make sure I showed each part of those. And I've got them written over here if you need to, so we can kind of keep on reflecting back on it. Okay. The rest of these are down lower. I'm just not going to Right a minute there. So it says, find the following using this triangle. Again, the numbers or the letters, numbers that we're going to be using them a lot over and over. They're just going to go in different spots. And it'll make sense when we start getting to different triangles that only have two sides, that you'll be able to use the sides that we already have. So I've got triangle JKL. The hypotenuse is 13. I've got one side is 5, the other side is 12. So I'm going to start off with the sine of angle J. I kept those written in. So sine, again, is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So the sine of J, I want the opposite over the hypotenuse. So here is this angle that I'm looking at. The opposite of J is going to be all the way over there. So it will be 5, because that's the opposite, over the hypotenuse. The hypotenuse on this one is going to be 13. So for that one, I've got 5 over 13. When we are doing the sine, cosine, and tangent, having a decimal is going to be important because it really only works with decimals going in there. So I'll have you write it as a fraction first, and then write it as a decimal. So sine of J is going to be 5 over 13, or as a decimal, it will be 0.39. We're just going to stick with J to start with, because again, I'm just going to stick on this full left side. So this was my hypotenuse. Okay, this one was my opposite. This was my adjacent. So my cosine for angle J, we're still sticking with this one. Cosine, I'm going to look for my adjacent number. So that's 12 over the hypotenuse. My hypotenuse is 13. So I get 12 over 13. I can write it as a fraction. To write it as a decimal, I'm going to put it in as 0.92. My last one for tangent of J, I want to do the opposite over the adjacent. So the opposite for J is going to be 5 over 12. Written as a decimal, 5 divided by 12 is going to be 0.42. Feeling all right so far? A little bit? Okay, I'm going to erase these names. I'm going to grab a different color pen just so I can be consistent. Draw. Let's go for green. Okay, I want to do K this time. I want to use this angle over here. So I'm going to look at angle K. Before I actually write down what they are, I'll write them down. This is going to be still my hypotenuse. 12 is now going to be my opposite measure. 5 will be my adjacent measure. So for the sine of K, sine, remember, is going to be opposite over hypotenuse. So I'd have 12 over 13. Written as a decimal, that will be 0.92. Cosine, that'll be my adjacent over my hypotenuse. So I will have 5 over 13. As a decimal, that'll be 0.39. And then finally, tangent of K is going to be my opposite over the adjacent. So I have 12 divided by 5. 12 divided by 5. That one gives me 2.4. on a scale of I think I got it, again, I'm not saying you for sure got it, I think I got it, I'm still way lost. Holy buckets, where these triangles come from. Where you guys at? Okay. I want you to try this one. Those are the three that we already did. I want you to do sine, cosine, tangent of L, and then sine, cosine, and tangent of N. And I'm going to turn the lights on a little bit so that way if you have a solar power calculator, it can work. I'll give you 2 minutes, I guess. And I'll go over the answers. I really want to walk around and make sure you guys have it, but I'm out of time. So I'm going to write these ones down. Your sine of L, hopefully you had 12 over 37, because again, sine is going to be opposite over hypotenuse. It's going to be 0.32. Cosine of L is going to be 35 over 37. That'll be 0.95. Tangent of L is going to be 12 over 35. That'll equal 0.34. Sine of N, that'll be 35 over 37, or 0.95. This one is going to be 12 over 37 equals 0.32. And then this one will be 35 over 12, which will give me 2.9. Hopefully you had all those ones. Tomorrow will be a work day.